All right, 8th graders, good to see you today. In our next video here, we're going to look at the next 5 lessons that you have been assigned. So have your books ready. Lesson 147 is where we'll begin in just a moment. So have your books, have your instruction sheets. Nothing's changed. Do all your work, show your work, tear the pages out so that you can turn them in, and do your very, very best. Just 5 lessons for you to do. Due on April 27th. Not going to be very difficult for you. To start with today, we look at volume. All right, you've already done volume starting at lesson 145. Remember, you've already done volume of a rectangular prism. V equals LWH. You've also already done volume of a cube. V equals E cubed. You've done volume of a square pyramid. Remember that square pyramid being 1/3 of the rectangular prism. Therefore, the formula was 1/3 LWH. Today, we look at cylinder and cone. Cylinder and cone. That's lesson 147, page 361. Very simple, just 2 more formulas for you to learn. And obviously the cylinder, looking like a canister, a silo. It is circular, and we're talking again about the volume, the capacity inside that shape. So that formula is going to involve the radius, and it's going to involve pi, of course. So you see on page 361, in that first paragraph, there it is, V equals pi r squared h. All right. Always find the answer to the nearest hundredth unless otherwise instructed. So you're just going to take that formula and you're going to substitute in to solve for the volume of the cylinder. So you look at the example problem. The radius is 5, the height is 16. So we substitute in pi, 3.14. Substitute in 5 for the radius, so we have 5 squared. Then we substitute 16 in for the height. We're going to do the exponent first, so 5 squared is 25. Then we're going to multiply 3.14 times 25 times 16. In whatever order you want to multiply those factors, whatever is the simplest way is fine to get those answers. All right? One more shape to finish out lesson 147 and to finish out these topics of rectangular or solid shapes of all kinds, these 3D objects. It's a cone. So on page 362, you see a cone. A cone would fill 1/3 of a cylinder. Therefore, the formula for the cone is 1/3 of the formula for the cylinder. So 1/3 pi r squared h. Very simple. It should be easy to remember. Rectangular prism and square pyramid, they go together. And then the cylinder and the cone, they go together with the volume. 1/3 pi r squared h. Now remember, I can take 1/3, since I can multiply at any order of these factors, I can do it at any point. So let me show you what they've done there. After they substitute everything in, 1/3 times 3.14 6 squared, and the height was 10. Okay? So 6 squared is, and I'm going to go ahead, I'm not going to rewrite it here, I'm going to go ahead and jump to this. 6 squared is 36. Now, I can multiply in any order. So I'm going to look through these 3. Are any of them divisible by 3? 36 is. So it's easier, class, to go ahead and take 1/3 of 36. It's 3 into 36, it would be 12. Okay? Then, I can do that in my head. Then I can multiply 12 times 10 in my head as well. 120. So the only tough multiplication I have to do then would be 3.14 times 120. Just to remind you of that little step that might help you to make your work a little easier for you. We're always interested in doing it the easiest, most simple way. Okay. Lesson 148, guys, is a review lesson over geometry. You're set up to have a test in lesson 100 and, well, maybe not. Anyway, you got to review all of that geometry that we have been doing on lesson 148. So complete all of that. And then that takes us to the next lesson. We're starting a new unit in lesson 149. Lesson 149, we're going to learn a little trigonometry today. We're going to learn to use Pythagorean Rule. You did this last year, but we'll review it and work a few together. Pythagorean Rule has to do with a right triangle. So I already have a right triangle drawn up here on the board for us. I already have it labeled. So we need to look at this and understand. We know what a right triangle it is. It has a 90-degree angle. So we need to look how to label it. They've labeled it A, B, and C. The legs that are adjacent or connecting to the right angle here directly are called legs. These sides are called legs. The side directly across from the 90-degree angle, the right angle, is called the hypotenuse. Very important that you understand what the legs are and what the hypotenuse is. You see that word, learn how to spell it there. And to solve these problems today, we use a formula, a rule, or a theorem that Pythagoras, a Greek mathematician, figured out a long time ago. He figured out that if I know the length of the legs, I can find out what the hypotenuse is. Using c squared equals a squared plus b squared. In other words, the square of the hypotenuse is equal to the square of the legs added together. That's what it means. He figured that out. So we can also use this. If we know the hypotenuse of one of the legs, we can figure this out to figure one of the legs. And we're going to be doing both in today's lesson here. So let's jump right to it and let's solve these. The first example problem gives us a right triangle dimensions having legs of 5 and 12. Legs of 5 and 12. And they want us to find the hypotenuse. Now, I have the right triangle drawn here. It's not in proportion to what they've given, but we're still going to use it. Okay? So A, let's say A was the 5, B was 12, and we know this is the hypotenuse, the long side, across from the 90-degree angle. We're finding C. So we're going to substitute in for A and B in our formula here. So C squared equals A squared plus B squared. All right? We're going to solve this equation like any other equation. We're going to simplify everything we can first. 5 squared is 25. 12 squared is 144. We add those together and we get 169. So we get down to this point. C squared equals 169. Now we still want to get C just side by itself. So we're going to take the square root of both sides. That's how we always end up these equations. That's always the last step, finding the square root of both sides. The square root of C squared is always going to be C, because any letter, C squared equals C times C. Okay? A squared equals A times A, for example. All right? So, square root of C squared is C. The square root of 169 is 13. It is a perfect square. Now, students, you are able to use the chart, the table of squares and square roots in the back of the book. Some of these will not be perfect squares. You will not know the answer to. You'll get down to this point and you'll have to look it up. Now, you may not have known what 169 was. So if you turn to page 419 and you look up 169, you will see the answer, the square root is 13. Okay? So you can use that. Now some of them, again, you will have to use that to be able to get the answer. All right, let's look at the next one. They give us one more to do here. So in this example, find the length of the hypotenuse if the legs are 4 feet and 5 feet. So 4 feet and 5 feet. Using the same formula, c squared equals 4 squared, a squared, plus 5 squared, which is b squared. I'm going to solve. 5 squared is 25. C squared. Okay, add these two together. 16 plus 25 is 41. My last step, as always, find the square root of both sides. Do I know the square root of 41? Is it a perfect square? No, it is not. That is why we look to the back of the book, the table of squares and square roots. We look up 41 and we round it to the nearest tenth because the instructions told us to give the answer to the nearest tenth. Final answer, c equals 6.4. So we can come up here and say hypotenuse is 6.4. Again, watch this over and over again if you want to see me work those again, or just look at the example problems. You'll have no issues there. On page 368, class, you can skip the problem-solving strategies at the top of the page. You don't have to do that blue box. But I do want you to look at the bottom, because in this lesson, we're also going to find the length of a missing leg. Okay? Because remember, as I said a moment ago, using Pythagorean rule, if I know the hypotenuse and I know the length of one of the legs, I can find the length of the other leg. So let's look at the example here, and it's solved a little differently, but nothing that you haven't had before in solving equations. So they tell us that the length of leg A is 5 feet, and the length of the hypotenuse is 13. So hypotenuse, or C, is 13, and the length of A is 5. Let me make sure I wrote that down, right? Yes. Okay. So now, guys, I'm going to take this same formula, and I'm going to fill everything in. C squared equals A squared, which is 5, plus B squared. We don't know what B is, so we leave it as B squared. And you'll see what we're going to do in just a second. First step, class, solve what we can. 13 squared, we've already used that one in the previous example, so you ought to know that that is 169. 5 squared is 25 plus B squared. Now, very important, at this step, we're going to use a rule that we learned previously. All right? I'm solving for B. Remember, I'm allowed to flip the sides of this equation as long as I leave everything in place. So I'm going to do that now. I want to get my variable, my unknown, on this left side of the equation. So I'm going to rewrite. Notice I'm not changing what is together. 25 plus B squared, I'm simply rewriting it in a different order, but I'm taking this and putting it on the left side of the equation. I'm taking the 169 and putting it on the right side of the equation. I'm allowed to do that, and it will help you. I recommend you doing that every time. Now look what we've got. We want to solve for B. We need to get B on the side by itself. We're going to do the opposite operation, so we're going to subtract 25 from both sides. Okay, cancels out, leaves me B squared. 169 minus 25 is 144. Now this looks familiar to what we've been doing. We're going to take the square root of both sides. Square root of B squared is B, and the square root of 144 is 12. B equals 12. The other length of our leg is 12. Okay? There we go. Good job. Again, watch it over again if you need to make sure that you get it. Hopefully we can see the bottom of this board. No problem. Make sure that you can see that and see all the work that I've done there. So go back and watch it again if you need to. All right, the next two lessons still continue to deal with Pythagorean Rule. And moving on from that, we deal with the right triangle, finding 3 trigonometric ratios. Okay, we're going to do 2 of them. We'll save the other one for later. The trigonometric ratios are the sine, the cosine, and the tangent. And we're going to use the lengths of the legs and the length of the hypotenuse to find those answers. And it's not difficult. You do need to memorize the ratio. You also are going to need to memorize the relationship of each side to the angle we are working with. And we'll go over every bit of that. Trigonometry means triangle measurement, okay? And the first one we deal with is the sine, all right? So if you look at the triangle, we'll try to use the one that I've got here, okay? We look at this right triangle here today. We'll leave this one up in case we need it. If you look at it, we first want to label it, knowing that this is the hypotenuse, all right? And knowing that we have 2 legs. But now, guys, we are going to identify these legs further. Now, notice in this example, I'm on page 370 right now. I'm not on the example problem. I'm on page 370, and I want us to look that they have labeled these, the right angle is B, this angle is A, this top angle is C. And the little arc shows that that is the angle that I am dealing with, okay? And in a moment or two, guys, you're going to take a protractor and you're going to measure the particular angles, okay? So if we were measuring angle A, we would get on here and we would line it up, see where it goes, starting with a 0, it's 40 degrees. Okay, we're going to use that in a few minutes. Because you can find the sine, the cosine, and the tangent by measuring an angle and looking it up. But we're first going to use this ratio. All right? So notice, since we're dealing with angle A, all right, there's going to be an opposite leg and an adjacent leg. Now, just remember, everybody knows what opposite means. So you look at the indicated angle and take your finger directly across. It's never going to be the hypotenuse, okay? It's going to be the opposite leg. So if we take our finger from indicated angle A, and we go across here, this is a leg, and this then obviously is the opposite leg. Now this is one way to figure it out. It's easy to know the opposite. So if this one's the opposite class, then what is this one? Yes, the adjacent leg. Okay? Now, why is it adjacent? Adjacent means right next to. And I'll go a step further and say that it is actually connected. All right? So indicated angle A, the leg that is next to it, that is connected to it, is the adjacent leg. So now, guys, we have identified hypotenuse, opposite leg, and adjacent leg. Now, all we need to know is the values. And we're going to look at that in the next page. But first, we are going to learn the ratio. It's always the lengths. The length of the opposite leg over the length of the hypotenuse. That's what you need to remember. Sine equals length of opposite over hypotenuse. Okay? So now, guys, look with me at example 9.3. All right, and maybe easier to try to draw real quickly this, and I'm not going to measure it, okay? I'm just going to get it close. I'm going to just make it the same direction that we have in our book. So I'll get my right angle as close as I can. It's not going to be perfectly straight, but we'll get it close with my straight edge. Okay, so you can see that's pretty close. There we have our 90-degree angle. Now, they labeled it B, just as we did in the other example. We got angle C here, and then we've got angle A here. Now, the problem says find the sine of the indicated angle. All right, and write it as a ratio and as a decimal. We'll talk about that more in just 1 second. And round the decimal to the nearest thousandth. You're always going to do that. You're going to have 3 decimal places. Now let's fill in the information. So this top side is said to be 6 inches. The hypotenuse is said to be 10 inches. And then our other leg is said to be 8 inches. Okay? So here we go. I have duplicated what's in your book right here on the board so everybody can look with me. Now, remember, here's what we're finding, guys. The sine of the indicated angle. That's the only thing I didn't mark. The indicated angle in this problem is C. All right? So we're going to find the opposite over hypotenuse. So, guys, we start here with the angle, indicated angle. We're going to take our finger and go all the way across to the opposite leg. See what I did? What is it? Yep, 6. Okay? And then length of opposite over hypotenuse. Do I do anything with the other leg? No, not for the sine. We use the adjacent leg for another ratio, okay? So here we go, 6 over 10. We're always going to reduce, class. It reduces to 3 over 5. So in your homework, for part of it, you're going to have 2 blanks. They're going to want another ratio. The answer to the ratio, 3 over 5. They're going to want to know now the decimal, okay? Now, 3 over 5, guys. We already know that when we should have memorized it. 3/5 is equal to 0.6. I always go to the nearest hundredth, so the answer is 0.600. You say, wait a minute, I don't know. How do we figure that out? We divide denominator into numerator. Remember this. Add my decimal point and zeros. 5 into 30 goes 6 times, and it comes out even. So we know, boom, 0.600. You should have that memorized, though. Okay? All right, there we go. We found the sine of that example problem. If you look at the very first problem, guys, in your practice problems, you're finding the sine of angle A. In the top blank, they want the ratio. So the sine is opposite over hypotenuse. Take your finger from angle A. Opposite leg is 3. The hypotenuse is 5. 3 over 5. It's exactly like the one we just did. Okay? So hopefully you're able to do that. Now, on page 372, it shows you, I already gave you a head start here. It shows you how to measure an angle and then look it up. Now, real quick, I don't think you'll have any problems. I measured angle A already. I put my vertex on angle A, measured it out, and then you'll look it up. These are easy, okay? So for the example problem, example 9.4, if you take your protractor, it'd be hard for me here because I have a big one. I didn't bring a small one over here. If we're measuring angle B, we're going to put our protractor vertex on angle B, all right? And we'll try to look at it and it is 45. Measure it. Then turn with me, everyone, to page 420. On page 420, you have a table. And all you need to do is look up the measurement of angle 45 degrees. And they give you the sine, the cosine, and the tangent answers. All right? So we're doing sine today on this lesson. 45 degrees, the sine is 0.707. Hopefully you can do that. Turn to page 420. You measure the angle. The angle's degrees where it's 45. You look under sine. It's 0.707. There's your answer. Those are pretty easy. All right? That's all you got to do. Measure them and write in the amount. If you have a question, again, send me a message in my schoolwork, so I'll try to help you. Answer that. Okay, one more lesson in this unit. Lesson 151. The cosine. All right? Same exact thing, guys. Everything we've done, identical, except the cosine has a different ratio, obviously. I'll leave sine up there so you won't be confused. But if you look on page 374, you'll see the cosine ratio. And you need to memorize this. It is adjacent over hypotenuse. Okay? Adjacent over hypotenuse. So we can look at, and I'm sure they have one. Well, here, there's similar numbers here. We'll look at it. It's the same triangle as the other example problem almost. So we take the adjacent to angle C is 8. See, that's the one that's connected, not the opposite, the adjacent, over the hypotenuse. So it's 8 over 10. We reduce that to 4 over 5. There's my cosine ratio. My cosine decimal then would be 4/5 as a decimal, which is 0.800. You should have that memorized. If not, divide 5 into 4, so on and so forth. This lesson is exactly like the sine. You just have to use the right ratio, okay? Finding the sine opposite over hypotenuse. Finding the cosine adjacent over hypotenuse, okay? And you can look back, watch the video again if you need to, and see where the hypotenuse is if you get mixed up, the adjacent and the opposite legs. That is what you need to keep in your mind. Keep that straight. Just as finding the sine by measuring, you also can find the cosine by measuring the angles with your protractor. Take your protractor, measure each angle, look it up on the table on page 420. There you'll see the sine, the cosine, and the tangent. Just pull off the one that they're asking for, write it down for your answer. Now, I didn't assign the tangent, lesson 152, but you could easily do it. And if you really have time, and you don't have to, but if you're ready to go on ahead, I won't hold you back. I didn't want to give you too much work, but honestly, we should have went ahead and done all 3 of them together. The next lesson is tangent, okay? The tangent is just a different ratio. A third one. It is opposite over adjacent. And everything else is just the same as how we solve them. So guys, what do you need to know? You're going to have to know the ratio for a sine, ratio for cosine, and then in the next unit, you'll have to do the ratio of the tangent. Opposite over adjacent. So for example here, guys, opposite, 6, adjacent, 8. We would reduce real easy. Measure them, look them all up the chart. If you want to go ahead and do the next 2 lessons, you're more than welcome to, but you do not have to. I'll review this again, I'm sure. If we're not back in school, if we are back in school, guys, I'll go over this again. If not, you'll be doing this on your own anyway, so we kind of already reviewed it. Lesson 153 is an review lesson. there over geometry and trigonometry. So you be ready to do all those lessons. We've gone over all the material. Hope this is clear to you. If not, study those examples, study the video, do your very best, and I look forward to seeing you sometime soon. Have a great day.